friends, welcome back. So in this session we are going to discuss about DQ algorithm of circular queue, right? So in the last classes we discussed about insertion operation in circular queue. I think so you might have all watched those videos and you might have a clear knowledge about how to implement that algorithm, right? Then another condition which I have forgotten to tell in that last video is for checking whether the circular queue is full or not, we can even use that formula, right? So what I did in the last video, I have used if f is equal to 0 and r is equal to n minus 1. Okay, so instead of using this conditions for checking the queue is whether full or empty, I can use the formula as front equal to rear plus 1 modulo size, that is modulo max. So please make a note of it. So this is one of the formula which I have discussed in the previous videos, right? So instead of using this condition, we can also use this directly. So if this condition is equal, I can tell that my circular queue is full. Okay friends, so please make a note of it. So now we can go for this deletion discussion. Okay. So now what is this operation? Okay. So as I told in this is the for loop used for getting each and every element from the queue. What I should have to do if one element is coming from the queue. For one element, all these operations will be checked. For another one element that is being fed, we execute all these steps. Okay, so like this it will be repeated until we have inserted n number of elements, that is less than n number of elements. Okay friends, so the same variables only have used in the last algorithm. If you cannot understand what is the use of all these variables, I request you to watch that video. And friends, I will just give it to you in the description. You can click and watch it, right? Okay, see the same structure I have used. So this is a circular queue representation and this is the internal representation of my circular queue data structure in memory. So now if you see, initially there are no elements present in the circular queue. So shall we start inserting the elements? Okay. So now see for the conditions. So f is equal to r equal to minus 1. So when you visualize this structure, is this condition true or not true? Please think and tell me. So this condition is true. Yes, you are right. Because front and rear pointer are not having any roles to play because there are no elements present in the circular queue, isn't it? So this condition is true. Initially the pointers are outside the data structure. Okay, so this condition is true and we are printing the value as empty, right? So if this case happens, what will be the result? So that we are going to see, right? So eventually this condition will be false because front value is 0 and what is the rear value? Rear value is 4. Okay, so this condition is false. So now we check for this condition. Front is equal to rear. What is this meaning? Front is equal to rear. So what is front value? So front value is 0. Rear value is 4. So this condition is also false. So friends, I will tell you this possibility once when this condition is coming over here, right? Since both the conditions are false, we are executing this statement, right? So now item is equal to alphabet of f and we are incrementing the front pointer. So what is the formula for incrementing the front pointer? This is the formula. Front is equal to front plus 1 modulo size. So please make a note of it. It is used for incrementing the rear pointer to one location exactly, even if there is a possibility for making the pointer to reinitialize to the first location. So for all the cases, this possibility will, this formula will work out well. So right, so this is going to eliminate all those condition checkings for reinitializing or incrementing the front pointer once the element is deleted. So this is an efficient formula for the circular queue. Very important, make a note, right? So now we are deleting the element. Okay, so item is equal to alphabet of f. So we have deleted. So front will be pointing here. So where it will be pointing? So to this location, front. Okay friends, so once again front is equal to 1 and rear is equal to 4. So again this condition will be false. So this also will be false because it is 1 and this is 4. Again this will be executed. So once again delete this element. Okay, so delete this element, right? Increment the rear pointer. So what is the initial rear pointer? So rear pointer is 1. Okay, 1 plus 1 divided by size. So what is size value now? Size value is 5, isn't it? So 2 divided by 5, you will be getting the answer as 2. So now the front pointer is going to point to this location. So here if you see, front is pointing to this location. Okay friends, so now once again start checking the element. This condition is false once again because front value is 2 and rear value is 4, right? So here this also will be false because 2 and 4 is not equal. So again you execute this statement. So delete this element, right? So delete this element and increment the rear pointer. So front is equal to, what is front value? So front value is 2. So 2 plus 1 modulo size is 3. 3 divided by size is 3. So it is going to point to this location front, right? Friends, are you all clear? Right? What is the use of this formula? So similarly I am showing here also. So front is equal to 3 and 3. Okay. So once again, what is f value? So f value is 3, right? So this false. So this also will be false. So now again execute this same formula. So remove this element. Remove this element. See, I have removed. So I want to increment the pointer. What is front value? Front value is now 3. 3. So 3 plus 1 is 4. Okay. So modulo remainder of size is 5. So modulo 4 modulo 5 is 4, isn't it? So we are making the front pointer to increment here, front. Okay. So here also it is pointing to front. Okay. So now what is front value? Front value is 4. So now check the condition. So this is eventually false. So now you see front is equal to rear. So here if you see, both the conditions are true. See, front value is also 4, rear value is also 4. Okay, so now what will happen? We are going to remove this element and we are making the pointers to come out of the data structure. Okay friends, so what we are going to do? We are removing the elements. We are making the pointers to come out back of the data structure. So now f is equal to r is equal to minus 1. So here also the same case, we are removing the pointers. Okay, so f is equal to r equal to minus 1. So finally after deleting all the elements, once again the circular queue is going to be in this representation. So in this algorithm, this is a special case. Okay, we cannot use this in the formula because we are making the pointers to go out of the data structure, that is go back to this condition. So we cannot use this because what will happen? So front value is initially 4, isn't it? So front value is 4. If I write over here 4 plus 1, so 4 plus 1, what will be the answer? You are getting the remainder as 0. So what will happen? So once again the front pointer will start to point to this area. So this is not a valid operation. So for that case only we are using a separate condition for making the pointers to come out of the data structure. Friends, are you all clear why we have used this separate condition? Right. So this is the overall algorithm for circular queue. Friends, I think you might have got a clear idea about how to implement this algorithm. So important points to make a notice, these conditions and this formula. Okay, so in the examination we are going to give a focus on all those formulas, right? What are all the conditions necessary, what is the place of the front and rear pointer, so all these things, right? Friends, now can you please tell me the time complexity of this deletion operation? So it is also the same as that of the case of the NQ algorithm. Okay, so the NQ algorithm we have discussed that the time complexity is O of 1 because we are giving the main focus on the rear pointer. But here we are giving the main focus on the front pointer. Okay, so the front pointer is also For each and every operation, we are making only one move. We are not making n number of moves, right? So, the time complexity of front pointer, that is the deletion operation also, we can tell that it is O of 1. Okay, can you understand? We are not making n number of moves for making a deletion. Just by one move, we are deleting an element. Okay, wherever the position of the elements may be. Right friends? So please make a note of it. For insertion and deletion of circular queue, the time complexity is O of 1. Right? Thank you.